So there's two major things we have to know when finding the probability of something. We're going to see keywords in our questions that say and, so find the probability of this and this, or find the probability of this or this. So and means that we are multiplying, and or means that we add. So two major things. Sometimes it won't explicitly say and or, but we can read the problem and think about what it means. Are they trying to say we do this and this or this or this? So we'll see that in the first example. And then another thing we need to know about probability is that it is always what we want divided by the total. And probability can be written as a simplified fraction, a decimal, or a percent. So if a quiz or test was multiple choice, just look at your answer choices. If you had 1/4, you know that is 0.25 or 25%. So just see whatever your answer choices are in, you may have to give your answer in a different way. The probability can be expressed these three ways. So let's look at example 2. 2a. Two coins are tossed. What is the probability that they both land heads up? So we're tossing two coins. What are our two possibilities that we have when flipping a coin?
Heads or tails.
Heads or tails. So we have two things that it could be. So our total things that it could be is 2. We're flipping two coins, so we have two fractions here. And we're looking for what's the probability that it lands on heads. So it would be 1 out of the 2 and 1 out of the 2. So we're tossing two coins. Do we flip one coin and flip the other coin, or flip one coin or flip the other coin? Is it and or here? And. We flip one coin and flip the other one. So this means we need to multiply. So what is 1/2 times 1/2? 1/4. 1/4 can be written as what in a decimal? 0.25. And what is a fraction? I mean, as a percentage, 25%. So these are three answers for A. Now let's look at B. Any questions on A? All right, B. A card is drawn at random from a standard deck of playing cards. What is the probability that it is an ace? So frequently, probability questions are going to ask you about playing cards. I would familiarize yourself with a deck of playing cards. On Canvas, I posted another little PDF of a deck of cards. So there's 52 cards in a deck. So 52 is our total amount. So from a card is drawn at random from a standard deck of playing cards. What is the probability that it is an ace? How many aces do you think are in a deck of cards? 4, thank you. So we have 4 out of 52. Can we simplify this? Simplifies to what? 1/13. And then what would this be as a decimal? .076 or 77 because we would round up. And what would this be as a percent?
7.7%.
Perfect, 7.7%. So the number of colleges and universities in various regions of the United States in 2008 are shown in figure 8.15. One institution is selected at random. What is the probability that that institution is in one of the 3 southern regions? So remember, when finding probability, we need what we want over the total. So what we want is going to be one of the 3 southern regions. So we have West South Central, East South Central, and Southern Atlantic. So what would go on top of our fraction here? So it gives us the number of colleges. So we have to add all of them. So this would be 406 plus 286 plus 754. What's going to go on the bottom of our fraction? What's the total?
Is it all of the regions?
All of the regions added together. So we have 581, 304, 453, 668, 265, 630, 754, 286, and 406. So we add all of these up, and that would be our denominator of our fraction. I got 4,347. Did anybody else add them together?
Yeah, I got the same.
Okay, perfect. And then we need to add the top, so 406 plus 286 plus 754. And that gives us 1,446 on top. Then we divide. So what would we get as our decimal? .333. And then what would our percentage be?
33%.
33.3%. Perfect. So this would be the probability that the institution is in one of the 3 southern regions. All right, next we have 2 different types of events when dealing with probability. One of them is overlapping. So we use this when we have some overlapping going on. And then we would use the second formula down here when it is mutually exclusive. So these are 2 different types of probability, which it doesn't really make a lot of sense in the formula here, but we'll do an example and you'll see what this means. So let's look at example 5. So one card is selected at random from a standard deck of 52 playing cards. What is the probability that the card is either a heart or a face card? So we need to find the probability that it is a heart and the probability that it is a face card. So let's find our probability that it's a heart. How many cards? Face cards are Jack, King, or Queen. So let's see. In our deck, we have 52 cards. So that means we have 13 hearts, 13 diamonds, 13 clovers, I guess. I don't know what they're called. And 13 spades.
Clubs.
Clubs. Thanks. I knew it was wrong when I said it, but each suit has a jack, queen, or king. So those are the face cards we're talking about. Jack, queen, or king. The ones with faces on it. Jack, queen, or king. Jack, queen, or king. So how many face cards do we have in a deck? 12. So we have 3, 3, 3, and 3. Are we finding the probability of one or the other, or the probability of hearts and face cards? Does it say or and in our problem? Or, so we add them. However, here we need to check if we have some overlapping going on or if these are mutually exclusive events. Do we have any cards that are both hearts and have faces?
Yeah,
3. So we have overlapping here with these 3. So because it's overlapping, we have to subtract the ones that are overlapping. So we're subtracting 3 out of our 52 cards. So everybody sees how we have those 3 cards that are overlapping? Perfect. So now we just add and subtract our fractions together. Our denominators are the same, so our denominator stays the same. Then we have 13 plus 12, which is 25, minus 3, so 22. 22 over 52. Can we simplify this? What does it simplify to? 11 over 26. Perfect. So 0.42 is our decimal. So that would mean we have 42%. I'm going to do another problem down here that's not in the notes. Yeah. Because we subtract 3 because we have 3 that overlap here. So whenever you have overlapping, you have to subtract what overlaps. We have 3 cards that are both a heart and a face card. So because it overlaps, we have to subtract those 3. Okay, let's say we need to find the probability that we have a 3 still in a deck of cards, or the probability that it is a face card. So what's the probability that we have a 3? How many 3s are in our deck?
Four.
We have 4 3s. Or means that we add or multiply. Add. And then how many face cards do we have in our deck?
13. Or
12. We have 3, 3, 3, and 3. So 12. Do we have any cards that overlap here? Are any 3s face cards? Or any face cards 3s?
Yeah.
You can have a 3 and a face on the same card? No, we can't. So none overlap here, so we don't have to subtract anything here. We're just going to add these together. So this would give us 16 out of 52, which simplifies to 4 over 13. The Human Resources Department of a company has compiled data on the numbers of employees who have been with the company for various periods of time. The results are shown in the table. An employee is chosen at random. What is the probability that the employee has 4 or fewer years of service? So remember, when finding probability, it is what we want over the total. So what's our total number of employees? How do we find the total? We add all of these up together. What do we get when we add them? 529. And then we want 4 or fewer years of service. So what number do we need to look at for 4 or fewer years of service?
157.
157. So what we want is 157, so that goes on top. I don't know if we can simplify this fraction, but we can divide it to get our decimal. What do we get when we divide these two? 0.297. So what is this in a percentage? 29.7%. Let's look at B. So now we want to see 9 or fewer years of service. .465, which is 46.5%. Any questions here? Okay, we have a couple more examples down here which are not in the notes, so if you want to take a screenshot of this, put it in your notes. You can write it down, but it's kind of a lot to write. I would just make sure you write this down or just screenshot it all. Alright, so in probability, especially when dealing with marbles or like something that you are like choosing at random, I guess. It doesn't always have to be marbles, but usually you'll see like marbles or balls or something like that. We have with replacement or without replacement. So if I had a bag of 10 marbles in it, and I pick one out, and I don't replace it, how many marbles do I have in the bag now? 9. So you always have to be careful if it says with replacement or without replacement, because that will change your denominator. It'll change your total number of marbles that you have. So with replacement means that I take the marble out, look and see what color it is, and put it back in the bag. So then I still have 10 marbles in the bag. Without replacement means that I take it out, put it on the desk, now I only have 9 marbles in the bag. So let's look at number 1. We have 8 marbles in a bag. 4 red, 2 green, 1 yellow, and 1 black. Without replacement, what's the probability that we have 1 red and 1 yellow? So without replacement means that we are not putting it back in the bag. So at first, we have 8 marbles in the bag. What is the probability that we take one out and get a red marble? So our total, our denominator, is 8. What's our numerator going to be? 4, because we're looking at the red marbles. So 4 goes on top. Now we're not replacing it. So the second time we put our hand in the bag, how many marbles do we have? 7. So our denominator is now 7 because we only have 7 marbles total in our bag. What's the probability that we take one out and we get a yellow? 1, because there's only 1 yellow one. Are we going to multiply these two together or add? Multiply, because it gives us that keyword and. So we multiply these two. So just multiply your numerators. We get 4 on top, and multiply the denominators. So 4 over 56. What does it simplify to? 1 over 14. Any questions on that one? All right, next we need to find the probability that it is 1 black or 1 red. So first let's find the probability that it is a black marble. So we pick a marble out of our bag. How many marbles total do we have to begin with? What's our total? What's going to be in our denominator? How many marbles do we start with? So we start with 8. What's the probability that it is black? What's our numerator going to be? 1. Next, we want to see what's the probability that it's red. So again, it is without replacement. So we took that first marble out, put it on the table. How many marbles do we have in the bag now? 7. And what is the probability that it is red? How many red marbles do we have? What's going to be our numerator here? 4, because there's 4 red ones. Now our keyword is or, so does this mean we multiply or add? We add them. So when adding fractions, we need to make sure we have a common denominator. So I can multiply the top and the bottom of the first one by 7. So I get 7 over 56. Then I would want to multiply the top and the bottom of the second one by 8. So I have 32 over 56. So that'll give me 39 over 56. All right, last example. Again, we have 8 marbles in a bag, 4 red, 2 green, 1 yellow, and 1 black. But here we have with replacement. So we take out a marble, put it back in the bag. So first thing we want to see, what's the probability that the first marble we take out is red? How many marbles total do we have? What's our denominator going to be? 8. And what's our numerator? 4. Next, we want to see if we can pull out a green marble from our bag. So when we pull out a marble again, how many marbles total do we have in our bag? 8, because we put the first one back. We replaced it. So again, we have 8. And then what's the probability that it's green? How many green ones do we have? 2. Our keyword here is and. So are we adding or multiplying? Multiply. So we just multiply straight across and straight across. So we have 8 over 64, which simplifies to 1 over 8. Any questions there? All right, last one. What's the probability that we have 1 green or 1 red? So what's the probability that it is a green marble? What's our denominator? How many marbles total do we have? 8. What's our numerator going to be for a green marble? 2. And then what's the probability that we have a red one? We replaced it, so 4 over 8, perfect. So we still have 8 marbles in our bag. And then our keyword is or. So are we adding or multiplying?
Adding.
Adding. So our denominators are the same here. So we just add the numerators. We get 6 over 8, which simplifies to 3 over 4.